Hello everyone, my name is Timothy Lee Grant, and today we are continuing our LeetCoding journey, trying to improve going topic by topic by topic. So the method that I'm trying to do to get better at LeetCode is do it one topic, get good at this topic, and then move on to a different topic. So the first topic I did was depth first search. Then I moved on to heaps. Now I realized actually I made a mistake by moving to heaps, and the reason is because heaps are a data structure and not an algorithm. And I realized if you do that, actually what happens is you get understanding of the data structure, which is the heap data structure. So I know how to use heap queue now, but each problem was a different algorithm. And so therefore I was doing a bunch of random algorithms and it didn't help me progress in a systematic way. So I said, okay, well, I'm going to be changing things up. I'm not going to be continuing with heaps anymore. I'm going to be trying to figure out how to make my journey improving at LeetCode more efficient. So I'm going to be choosing a new topic, but I decided, well, hold on. I was going to do the learn and forget method where I learn one topic, I go on to another one, but then I have to go and revisit that old topic that I previously learned. So that's what we're doing today. We're doing depth first search. So this is something that I learned maybe 3 weeks ago, and I got fairly good at it. I could kind of solve mediums maybe 50% of the time, and then I moved on to heaps. Now it's time to go revisit depth first search, see if I'm still able to do it, try to put that into my brain. So let's minimize this and let's pick a medium. Why don't we do the first one, word search? That one is a medium. So why don't we try that one? That one has not been marked yet. All right, here we go. So, number 79, word search. Given an M by N grid of characters, board, and a string word, return true if word exists in the grid. Okay? So, I'm given a board here, and it has M rows by N columns. Okay? So a two-dimensional array, and that's what it's called as board. Good. So I'm also given a string called word, and now I need to search this board to see if word exists in this board. Okay. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontal or vertically neighboring. So as we can see here, A, B, C, C, E, D, this is the word, and I can check horizontally or vertically, so up, down, left, or right. And so I kind of need to make a little string like this. Okay, the same letter cell may not be used more than once. Okay, so we have just different examples. So here we need to see if C is in this array and or two-dimensional array. So come here, nothing, come here. Oh, here's an S. Here's a E. Oh, here's another E. So I think I already have an idea of how I'm going to do this. So the way that I'm going to do it is I am going to loop through each element in this two-dimensional array. I'm going to, let's actually use this one as the example. So I have C right here. So I know that the first letter is going to be this S. So what I'm going to do is I'm going to try to check the first element and say, okay, does this element, does it start with an S? No. So then I'm just going to go to the next one. Does this one start with an S? Nope. 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 Oh, here's an S. Okay, so then I'm going to start to do a traverse. So I'm going to do a traverse, and I'm going to say, okay, I'm going to check up. The next letter that I need is an E. So I'm going to check up. Is that part of this? Or is the vertically connected node an E? Nope. Okay, so I'm going to come back. How about to the right? Nope. How about to the left? Oh, it doesn't exist. It's out of bounds. How about down? Nope, that's not an E either. So then I have exhausted all of my valid paths. So I'm going to pop back out of that depth first search and say, okay, that wasn't it. I'm going to come here. No, that's not an S. This isn't an S. Here's an S. Okay, cool. I'm going to do a depth first search. I'm going to pop up. Hey, I found an E. Great, wonderful. So now on this one, I am going to check up, down, left, right. Okay, so let's check up, out of bounds. Let's check right, out of bounds. Let's check down. Uh-oh. We said that the same letter cell may not be used more than once. Okay, this is used more than once, so I can't use it again. So this is obviously something that a set is going to help us with. So right when I visit a node, I'm going to put it in a set if I include it. So before I traverse down into the recursion, I am going to put it in the set and say, hey, I used this letter, don't use it again. Okay, so not here, okay, here, and I check, nope, it's not another E, so we don't do anything yet. Then I say, okay, I'm going to check to the right, or to the left. Nope, that's not an E. I'm going to check down. Hey, it's an E. So I'm going to check up, down, left, right. Okay, so up. Oh, we already visited this one. Oops, out of bounds. Oops, out of bounds. Hey, it's an E. So now we can kind of end our search because we know that we have true. We know that we should just return true because we visited all of the letters in this word. Okay, so let's start to write some code to be able to actually perform this. Okay, so what do we need? I know that we need something which is like visited, okay, which is going to be equal to a set. Now, I don't know if I'm actually going to declare it up here because I know that I need to refresh it every single time that I do an attempt. So for what I mean by that is if I start here with S and then I don't want to, I'm going to put this S in this scene set and I'm going to try to come here. I'm going to try to come here. I'm going to try to come here. But then when I pop back out and then I check this one, oh, I found another S. I found a potential candidate. I don't want this brick or this tile to be counted in my scene. So I know that each time I come back, I need to kind of reset this scene or this visited set. So I'm not too sure about that, but we're going to come back to it. Right now we're just getting stuff on the page. So let's see what else we can do. What else might we need? We'll probably need like length, or maybe rows. Rows equals length of board, and then calls equals length of board indexed at the 0th. And now we obviously need to protect this statement here because if board is empty, we can't index something that doesn't exist. So we need kind of a blocker that says like, oh, if board doesn't exist, what should we return? So I didn't mean to put it there. Here, if not board. Okay, what do we do in this case? What makes sense? So first off, we might actually be guaranteed that m is 1 or is greater or equal to 1, n is greater or equal to 6. So actually in this case we don't need to worry about that because board will exist. There's always going to be an element in board, so we don't need to worry about that case. That's fine. Okay, let's just do traverse. Okay, and now what do we want to pass in? Well, we want to pass in the row, the column, and the word index. Okay, that's what I'm thinking. Now, we'll need this row. That's different than rows. So row tells me which row we are currently looking at. Are we looking at... So we just found this S. Where'd it go? Up here. Okay, we just came here. Now I want to traverse up, so I need to increase my row by 1. Does that make sense? And then I want to check right. I need to increase my column by 1. So this targets the two-dimensional array. Tells me what row I'm going to be looking at, what column I'm going to be looking at. Word index tells me, okay, so I just found an S. I need to find an E, right? So that's going to be the 1th index. The 0th index of word is S. The 1th index of word is E. So this word index kind of tells me which letter I'm looking for. Okay, so let's put a base case up. What would the base case in this be? Well, it would be, first off, if I've found all of the letters, right? So if word index is larger than or equal to word length, okay, return and true. So we say, hey, we found it. Okay, now we need word length here, so let's put that on the canvas. Word length equals length of word. Okay. So now, what are other base cases? Well, base case would be if we're out of bounds, right? If we're here and we try to check right, oops, we're out of bounds. So that means that column is greater than this calls. Likewise, if we're here and we try to check left, oops, we're out of bounds. That's column is less than 0. Okay, so let's put that base case up. So if row is larger than or equal to rows, or row is less than 0. In this case, what do we want to do? Return and false. Now, why false? False is, what I'm going to be doing is trying to pass up a true value. So I'm going to keep recursing down, and I'm going to have a call down here, which is part of traverse. So I'm going to be traversing the left, right, up, down. And what I want to do is I'm going to do an OR statement where if any of those calls found the complete word, it's going to stay true, and it's going to pass true up all the way and return true. Okay? If it doesn't find anything, then it's going to do false. So if every single search that I've done is false, it's going to return false. So coming here, I'm going to say false, but that doesn't mean that the entire thing is going to be false, because if I find one true, I'm going to be passing that true up all the way to the top. Okay, so this one is false, but that's fine. Now, what's the other case? So if column is greater than or equal to calls, or column is less than 0, in this case, we are going to return false. Now, let's think about this a little bit. Is it equal to? Okay, so this length of board returns the elements in board. So if board, this right here would be how many rows are there. So 1, 2, 3. There's 3 elements. Now, what is the index? The index is going to be 0, 1, 2. So that's why I said is equal to, because if it's equal to, that means it's actually out of bounds, because this one is how many elements, this one is what's the index. One is 1 indexed, the other one is 0 indexed. Okay. What about this one right here? So word index is an index. Word length is the length of the word. That's how many elements are in word. So that's why I have this equal to. If it's equal to, means it's out of bounds. We've gone one over. We found everything. We're done. Okay. So now, what's another base case? Another one is, so because rows is not out of bounds this or this way or this way, columns is not out of bounds this way or this way, we know that we are on the board, okay, somewhere. So we're free to now index because we don't want to try to index up here, because if we do that, we're going to get to the case where we're out of bounds and we're trying to index an element out of the bounds of the array. We don't want that. Okay, so let's we're free to index here because now after we've done those checks, we know that we're good. So let's check one last base case that we have, which would be if we're here and we look at this C, but that's not the letter we're looking for. We just want to return false. Say, no, we didn't find anything yet. So let's do if, and now we can index board indexed at row and column. So if this element does not equal word of index, and notice that a word index, I should say, word index. Okay, now notice that we've also checked if word index is outside the bounds of the array, so we know that we are allowed to index it. So if it's not equal to the letter that we're looking for, we don't want to keep doing a depth first search, right? I don't want to check above or below or to the right, left. I don't want to be doing that. I just want to return. And what do we return? We return false. We say, yeah, I didn't find it here. So let's return false. Okay, cool. So now we did find the letter that we were looking for. So what we can do is say, okay, great, I'm going to look for the next letter. So I am here, I found this S. I came down here, hey, it's an E, right? We first check, have we finished all of the letters? Right now we are on the second one, right? So, or the index 1. So we're looking for the first E. We're right here. We say, are we outside the bounds of this word length? No, we're not. Are we outside the bounds of the row? No, we're valid. Are we outside the bounds of the column? No, we're valid. Okay. Is this the letter that we're looking for? This E right here, we index it at 1. Okay. Is board of row column here, is that equal to the first index of word? Oh, yes, it is. Okay, great. So now we want to try to traverse, right? We want to look up, down, left, and right. So let's do that. But we also need to remember something about this visited set. So we need to make sure that we take into account this. Okay, so right now we're going to do what? Well, let's add this here to visited. Should I do that? Yeah, maybe. So let's see. How do I want to do that? Visited.add. Now what do I want to add? Maybe like a tuple of row column, something like that. Okay. So now what do I want to do? I need some way to actually take that off. I realized, I need to be able to append and delete from it. Okay. So let's just say like result 1 equals, and then let's traverse up. Okay, so how do we do that? Traverse. So we're doing recursion, and now we're going up. So row plus 1, row plus 1. Column is going to stay the same. Okay, and then word index is going to be the next letter because we found the one that we were looking for, right? So word index plus 1. Okay, so now we want to do that up, down, left, right. So this one's up, this one is down, this one is left, this one is right. So the only difference is this is going to be minus, and then this one is going to be plus 1. This one is going to be negative 1. Okay, and then this is going to be result 2, result 3, and result 4. Okay. So now I want to do what? I want to, can I do visited dot remove? I don't know if I can actually do this. Row column. I'm not sure if I can remove from a set like this. This is going to be a good experimentation right here. So I think I want to remove this because I want to say like, hey, I know that I tried to visit this E up here, right, from this S. I know that I tried to visit this E, but it didn't work out. So I want to pop back out, and when I pop back out, I want to kind of remove this element and say, actually, nah, just kidding, we're not using this E. So I'll pop out, and I'll take away this E. And now I can reuse it. Let's say that this was, let's say we're looking for, I don't know, S-E-E-E, right? So I come here, S, and this is an E. Hey, I got it. And then I come here, E, got it. And then I come here, E, A, got it. Like that. So I can use this E again if I come up here, I traverse and say, I didn't find anything. I come up down. I can still snake back around and reuse this E. Okay. So I want to remove it. And also, if you notice, we actually didn't check if the letter that we're currently at is part of set. So I just want to look here and say if row column in visited return false. False. Okay. So now what do I want to do? I want to pass up that variable. So I want to pass up this result 1, 2, 3, 4. So I'm checking up and say, did you find the complete word? Yes or no? I want to pass up this one. Did you find the complete word? Yes or no? So I want to find if we ever hit this base case here. So if any of those hit the base case, one of them will say, hey, true. And then I just want to do an OR operation. So I want to return result 1 or result 2 or result 3 or result 4. So if any of them return true, I want to say, cool, we're good. Now, let's actually call this traverse function. So for I in range, what did I call it? Rows. For j in range columns, if board of ij equals word indexed at 0, then traverse, and where do we want to start? Row 0, or sorry, we want to start at I, J, and 0. Okay, so what did I do just here? So what I did was I am going to go through all the rows and all the columns of this board. All of the rows and all the columns of this board. So here's this row right here, this row right here, this row right here. Each time I want to check, is the specific tile that I'm at, so let's say right here, is this tile equal to the first letter in the word? So is it equal to this word of 0? Is it S? No. If it's not, I don't even want to traverse. I just want to go to the next one. If it is, hey, I found a S. Great. Now I want to call my traverse, and what do I want to do? I want to start at this row and at this column. So I'm targeting this tile, and I want to start at the 0th index. So we're going to come here, and then we're going to see, this one is going to not hit, right? Okay, so then we're going to add the S, this S, to scene. Then we're going to go to the word index, the next one. So it's going to be the second E right here, okay? And then we're going to look up, we're going to look down, and so forth. Okay, so what this is going to return a Boolean, either true or false. So result equals here. Now, what did we say? If result is ever found to be true, we know that the entire word is in this board. And therefore, we can just return true to the entire algorithm, to the entire problem. So if result return true, else what do? Well, we just want to keep looking, okay? We want to keep looking through all of them. Now, if we've looked through the entire board and we haven't hit this case where result was true, that means we didn't find the word. That means we can return false. Okay, so let's see if it works. I'm a little bit hesitant on this guy right here. I don't know if I'm allowed to do that, but let's see what happens. Let's try it out. Okay, there we go. Nice. So I guess I can do this remove. I was actually expecting it to kind of fail. I didn't think I was allowed to do that with sets, but hey, learn something new. Okay, cool. Actually, that's pretty awesome. All right, well, thank you guys so much for watching this video. I guess this means depth first search is kind of like in my head a little bit, and I used the learn and forget, right? I learned depth first search, and I was struggling. I mean, I posted the video, so you guys saw, right? Like, I was struggling with depth first search. I couldn't get it, and it felt like I was making video after video after video of me just saying, like, I have no idea what I'm doing. I can't solve it. And then having to go to GPT here and ask it, like, hey, I couldn't solve it. And then doing the investigation portion of things. Like, okay, I wasn't able to solve it. Where were my mistakes? What can I learn from this experience? How can I make sure that I don't do it again? I kept hitting that wall over and over. And then I got to the point where I was like, actually, depth first search, I'm able to kind of regularly do mediums. So that's why I switched from depth first search over to heaps. Now, again, as I said at the beginning of this video, I actually made a mistake doing heaps. I should not have done heaps, and the reason is because heaps are a data structure, and it got to the point where I was doing a whole bunch of random algorithms, but that could use this data structure. So I understand the data structure, but the algorithms, because it was a bunch of random, like what I mean by random is different. each day I was doing a different algorithm. It didn't give me that opportunity to actually solidify in my mind any algorithm, so I wasn't improving as quickly as I was hoping. So moving forward, what I'm going to be doing is trying to figure out, like, okay, what topic do I want to address going forward? So this one, depth first search, like problems. So I need to figure out a different topic, right? Maybe like sorting or greedy, or I don't know. I need to figure out one that I think is uh, useful, helpful, and will give me a lot of value, and also is an algorithm that I can focus on one thing and get good at that one thing. So that's kind of how I'm going to be moving forward with my LeetCoding videos. If that's something that is interesting to you, I would love if you would subscribe. I just hit 100 subscribers today, so thank you to everyone who did subscribe. But anyways, I hope you guys have a wonderful day. My name is Timothy Lee Grant, and I will see you tomorrow.